Dear student, after defining the noise, we defined 5 types of noise: salt and pepper, Gaussian, Poisson, speckle, and local variance. And we see the influence of each type of noise. Now we need to define type of filters that are used to reduce this noise, and increase the quality of the image. So the simplest and the most important and most used is the mean filter, which is a low pass filter. It's used to smooth the image and to remove the noise. Which is mean filter, it means it's an average filter. Just we take a slide window and we take the average of the pixels. يعني بنجمع البيكسلز وبناخد الافريج. So equal weight for all pixels in the neighborhood. Which we have, if we have the size window of size n times m, rectangular or either squared window, so just the weight is 1 over n times m, and we add all the pixels, يعني بيجمعوا بقسمهم على هذا, which is n over m, and every pixel is replaced by the mean of n times m neighborhood. So mean filter reasonably effective for Gaussian noise, but it's not effective in case of salt and pepper noise. So for Gaussian noise, the mean منيح, but for pepper and noise, it's not good. Why? Because إذا عندي أنا pixels بالغلط بيضة 255, لما عم بجمع البيكسلز وبقسمهم على n times m, this value of pixel will affect its neighborhood. Let's say we have نقطة بيضة بقلب منطقة سوداء. So when we add the low value of pixels with 255 and we divide by n times m, with the size of the window, this value, white value, will affect all the neighborhood pixels. So it's not effective for case salt and pepper noise. Loss of high frequency image details as edges. When we apply mean filter, إذا عندي region of interest, إذا عندي edges الحدود, يعني edges الحدود بين two region. Let's say cameraman والباك جراوند تبعه أو الكوينز والباك جراوند الغامقة تبعهم على حدود اللي هن البوردرز. هالنقطة هيدي لما بدي آخذ ويندو، شو يعطيني هيدي الويندوز؟ رح يكون inside this windows points بالباك جراوند اللي هن السود وpoints بالفورجراوند اللي هن البيض. وبالتالي the average at the border will be affected لأنه رح يجمع أنا white pixels plus black pixels and we take the average, which means this border pixels رح يطلع لونها not white اللي هو الفورجراوند, not the black اللي هو الباك جراوند, but gray colors, which means that the border will be degraded, يعني مش رح يطلع مظبوط. So this is one of the disadvantages of mean filter. Also it causes blurring on the image edges مثل ما حكينا, because رح يطلع عندي ألوان colors not the black and white, which means that we have a blurring the image, مثل كأني أنا مسحت بإيدي colors. Also large windows cause degradation of the image. When we increase the size of the image and take the means, all the details will be removed. كل التفاصيل الموجودين بالصورة راح يمحوا لأنه راح ياخذ الافريج للكل, which means that we cannot use, or it's not good to use a mean filter with large window. And of course, it's not robust for large noise deviation. If we have a noise عالي كتير, deviation between noise, يعني when we have a noise, noise هو عبارة عن ضجيج. النويز الخفيف يعني بتكون we increase or decrease the value of original pixels by some values. يعني لما يكون أنا عندي بيكسل وصار في عندي ضجة حواليها, value of pixels راح تكبر قيمتها أو تصغر by some value. If this value is small, the mean filter can be good. But if this value is very high, إذا كان الخلل بالvalue كثير كبير, the mean filter منه good. Why? Because هذا الخلل, deviation of value, راح تتوزع على كل النيبرهود and all the neighborhood will be affected. يعني بدل ما يكون عندي بيكسل نقطة فيها خلل, راح يصير كل النيبرهود فيهم خلل, وبالتالي the quality of the image rather than to be more performant راح تكون quality very bad. So we take the image 8 and we apply salt and pepper and Gaussian filters. And after that, we use the image filters and we apply the mean filter. with the window k equal 1 is 3/9, which is 1/9 for the all, and we apply the mean filter. And we can see this size. So this is the original filter. This is when we apply pepper and salt filter, then we be filtered by the mean filter. This is when we apply Gaussian noise and to be filtered by the mean filter. So we can remark here with Gaussian filter, the quality is good in compared to the Gaussian noise here. This is the Gaussian noise. While with the salt and pepper راح تشوفوا الصورة it's not يعني it's good but not for the same quality of Gaussian filter. Now if we apply this for the Poisson noise, speckle noise, local variance noise, so this is the original, this is Poisson filtered. So mean filter, it's good, likely to the filters. It's not, it's okay, not very good compared to Poisson with the speckle filtered. And you see the effect of speckle and local filtered, also local variance filters. عم نشوف الديجراديشن خاصة بالديتيلز inside the coins and so on. Median filter, median m of a set of numbers. So we take these numbers and we order this number from minimum to maximum and to take the centered one. So it's like the midpoint of the sorted distribution bounds. هي بنسميها الميديان filter. So الميديان لأي statistically لأي set of bounds شو هو بصفر من صغير للكبير وبياخذ الترتيب والنص. فهو مش الجمع على اثنين، هو الترتيب النصاني حسب عدد البوينتس. So this is the median filter. Why median filter is so important? ليش median كثير مهم؟ لأن إذا عندي salt and pepper وبالتالي انا راح اخذ الرقم النصاني، فاذا كان عندي ارقام كبيره it will not be affected، واذا كان عندي ارقام صغيره will not be affected because I take the value at the centers, so they will not be counted into the calculation. So at each address pixels we take the pixels value, the pixel value is replaced by the median of the m times m neighborhood, and this method is very robust to outlier extreme values. لما يكون عندي ارقام صغيره كثير غلط او كبيره كثير غلط، لما اعمل sorted وياخذ النصاني هذه الارقام ما راح تدخل بالكالكوليشن. So and if we have salt and pepper they will consume each other. يعني اذا عندي نقطتين سود عطوا زيرو او نقطتين كبار 255، هذول النقطتين الصغار والنقطتين الكبار ما راح ياثروا كانه وجودهم وعدمه هو ذاته because the median points will be the same. So this is the way. So the median filter in general is superior to the mean filter and it overcomes its limitation. So it preserves sharp and high frequency details at the edges. بتحافظ على الedges. Eliminate noise, especially speckle noise. بتلغي النويز, speckle noise, وكمان ال salt and pepper noise. Prevent edge blurring and loss of details in the image. بتحافظ لي على الedges. Slight degradation in the image quality. It may cause slight degradation. بالنهاية we apply filter so أكيد بده يتغير شكل الصورة. But it requires greater computational cost for sorting. لكن مشكلة الميديان filter it depends, it needs time because every window كل ما ياخذ شباك we need to sort the numbers from the minimum to the maximum and take this the midpoint midpoint بهالsorting numbers. وبتعرفوا انتم sorting الالجوريثم of sorting it cost calculation. وعدوا كم ويندوز عندي اذا السايز of the image 700 or 400 by 800 and if, the window is 3 times 3 so كم window عندي وكاميرمان we need to apply sorting. So also we apply salt and Gaussian error noise and then we apply the median filter. So here as you see for the salt and pepper it's very perfect. It's very perfect. So median filter is perfect to salt and pepper. Gaussian okay is not with the quality of mean filter but it's okay. Now we apply the same noise, Poisson, speckle and local variance and then we apply the mid filter and this is what we apply mid filter to, so which is median filter 2 which means two dimensional because we applied it on the image. So this is the original, this is the Poisson, we see the quality, speckle filtered and local filter. We can apply rank filtered, which is rank filtered now is a nonlinear. It's similar to the median. So neighborhoods n times n is ordered in ascending or descending order, and we choose the order of the filter from 1 to n. يعني الاوردر فلتر بصف الارقام بالويندو من الصغير للكبير وبيختار الاوردر. بدي اول واحد which means the minimum، بدي النصاني ميديان، بدي الاخراني so mix maximum، بدي الاول 5% فبيعطيني الفايف الاوردر، بدي اخر 95 and so on. So each filter pixel is replaced by the value of chosen rank pixel. بختار rank of pixels قديش درجته او ترتيبه. Rank could be minimum معناتها الأولاني، الميديان midpoint الماكسيموم and so on. So it's conservative smooth filter because pixels replaced conservative smoothing filter. We have what we call conservative smoothing filter. Pixel is replaced if its value outside range min max. يعني في عندنا نوع من الفلتر بنسميه conservative smoothing filter. إذا البيكسلز IJ قيمته اصغر من الصغير او اكبر من الكبير بنحط المينيموم او الماكسيموم. So this is another kind of variant of rank filter. So let's take the rank filter. This is order filter 2. Order, it means you order the filter. Filter for filter and 2 for 2-dimensional. So I 25 ones 55. I'll take 1 1 for every time. So اخذت انا size of pixels size of window 5 ب5. 25 يعني اخذت اخر واحد معناتها الماكسيموم من 25 اللي هو 5 ب5 يعني 25 elements. I choose the 25 element which is the maximum. So every time I take a filter and of dimension 5 5 I take the maximum. طبعا what is the influence؟ رح نشوف white pixels اكثر بالصورة. But now it's filtered. We have a noise in the image. So here with the salt and pepper كل نقطة salt رح تعمل بلوك محلها لأنه أنا عم باخذ شو كل البلوك محلها. كل ويندوز 5 في نقطة بيضاء رح تصير النقطة بيضاء وبالتالي بيصير بلوك. So بالجاوشن also we applied using maximum. طبعا عم نشوف البلارينج يعني الجاوشن تحسن ولكن صار في degradation. الايمج ديتيلز تفاصيل الصورة ما عاد مبين تفاصيل الكوينز الموجودة. Okay. So by salt and pepper we amplify the noise. The noise بدل ما تصير نقطة صار a block of that. This is original max filter when applied without noise. This is when we apply the max filter with salt and pepper noise. This is when we apply the maximum rank filter with Gaussian noise. Now we take the minimum. Let's say the same. Take 1. This is the order 1 for 155. Now at the opposite, rather than obtain small blocks of white, we'll obtain a small block of a black than white. لأنه عم باخذ minimum which is 0 and will be 200 0 which means the black 0 يعني black. فعم نشوف نحن every points as pepper النقطة السوداء اللي كنا معتبرينها pepper as 0 will be enhanced and powered or amplified to be a block of light. طبعا عم نشوف Gaussian mean filtered. It's very bad image. So minimum is not good. Let's say now we take the point value 20 of 25. إذا أنا قسمته من 1 to 25 إذا أخذت 12 بكون عم باخذ الميديان filter. Now what's happened is I've take 20, if I've take 5, I've taken number 7, number 9. So you can play on this and every time apply this algorithm and change the order of the value. We take 20, 12, we take 7, 9, and so on, and see what is the order of the image. So this is rank 20. This is the when we apply the rank 20 on the original image. When we apply this with the salt and pepper, it's good, but we have some degradation on inside the image. But with the Gaussian, it's very, it's bad. Now we apply Gaussian filter. So we have Gaussian noise and we have Gaussian filter. So we have two types. We need to prevent the confusion between those two lines, two type of filters. So we have noise called Gaussian noise, and we have a filter called Gaussian filter. So Gaussian filter is very important filter. It's smooth the image remove noise effect and use as first stage in an edge detection algorithm. When we want to detect the edges in a noisy image, we have to apply Gaussian filter first, then we apply the algorithm of edge detection. And which is important that the Fourier transform of Gaussian function is also Gaussian. يعني لما طبق any transformation on Gaussian, we will obtain also a Gaussian. So this is important of Gaussian filter. Of course, when we talk about Fourier transform, we will see the importance of this Fourier transform. So as you know, the Gaussian filter, discrete kernel derived from a radially symmetric form of continuous 2D Gaussian filter. This is the function of Gaussian filter, fxy, 1 of 2 pi sigma square exponential minus x square plus y square over 2 sigma square. You know, this is the Gaussian function. Sigma is the standard deviation. And also sigma, it controls the smoothing because the size of the Gaussian. Now we talk about the Gaussian 2D Gaussian. يعني راح تصير مثل شكل الشبح أو الفينجر مثل إصبعكم يعني بس ولكن بالمقلوب يعني زي ما نشوفوا نحن as 2 dimension. طبعا if sigma is large, إذا أنا كبرت السيجما, Gaussian filter act as low pass filter with sharp edge features, where sharp edge features are suppressed. يعني أنا لما أكبر السيجما يكبر الحدود تبع الجاوشن أكيد راح الشارب edges راح يختفوا. So this is the form of the Gaussian. Like this is the function of Gaussian. والسيجما هي الفاليو. This is the value of sigma من هون لهون. So لما تكبر الشكل بيصير will be degraded. So also the same, we take F special Gaussian, as we said before, we take this Gaussian filter before, 5, and 2 is the standard deviation. We apply salt and pepper noise and Gaussian with the mean 0.25 and variance 0.2. And then we apply image filter with the K as the special filter. So we see that this is the original. After we apply the original image of applying Gaussian filter, we saw that it's good. Also when we applied on salt and pepper, and also when we applied to the Gaussian filter. So you see that the Gaussian filter is very important. It's a superior filter. Sometimes act on the details. This is the details. But in case of noise, it's a removable filter. So for that, if we have a filter and we want to apply further algorithm on the image, and we need to denoise the image, so we apply first Gaussian filter because it is very powerful filter. Now, if we apply Gaussian filter on Poisson, speckle, and local variance, also for Poisson, it's very important, speckle and local variance. Of course, when we compare these images to the first images, to the original image, we can see the difference. So this is when we apply this to the original image, when we apply image noise. So when we see these images, and we see the output of these images after applying Gaussian filter, so we can say the powerful of this of the Gaussian filter. Okay, now we pass for filtering for edge detection. I will end here and we'll take us another video for edge detection in order to not have a big size of the video. Okay, good work.